Alright guys, today we are going to work on the last part of 3.3, modeling with functions. You're going to need out some highlighters. You will need a green, an orange, and a yellow. I gotta go get my notebook. It's not right where it is. Okay, so in your notebook, we are on page 29. So we're going to go ahead and label page 29, 3.3, modeling with functions. It's where we're going to glue in the writing functions, and I'm going to go ahead and glue it in so I don't have to do that later. Modeling with functions on page 29. Okay, like I said, I'm just going to go ahead and glue it in. Save me some time in the end in a minute. Alright, so we already had modeling expressions where we wrote the word problems. Might lose out. That's what we're going to do today. We are going to still identify dependent and independent variables. So we still need some practice on that, I know. Okay. So we're focusing on writing functions. So the first question says, Jill opened a bank account with the $100 she received for her 14th birthday. To help save for a car, Jill decides to deposit $10 of her allowance each week into the account. Alright, we're going to highlight our important information. Jill opens a bank account with the $100 she received for her 14th birthday. To help save for a car, Jill decides to deposit $10 of her allowance each week into the account. We're going to come back to independent and dependent variables because I find that it's easier to identify them after I have a function, and you're going to see what I mean by that. So we're going to write a function. And it says be sure to use proper function notation. Here is what that means. I'm going to write a function of something equals, and then I'm going to write this. I'll decide my variable in a minute. So Jill starts with $100, so 100. She then deposits, that means she puts money in the account, $10, so plus 10, each week. I'm going to use the variable W to represent week. Whatever variable I choose here goes right here. F of W equals 100 plus 10W. That means the function of W is equal to this equation here. This is my function. I'm going to go back and fill in my independent and dependent variables now. My independent and dependent variables, now that I've written the function, one of the variables is week, the other one is the amount of money in the account. That's what F of W is going to stand for. F of W is just like Y, and Y is the dependent variable. So the dependent variable, the amount in the account, which means the independent variable is whatever variable I have here, and that is the number of weeks. So the amount in the account depends on the number of weeks. Okay? Now, I've got two questions I've got to answer. The first question is, how much money will Jill have after 23 weeks? Well, since W stands for weeks, I'm just going to plug that W in to this equation. Here's what it will look like. Everywhere I see a W, I'm going to put 23. This piece right here just means that I plugged in a 23. You will see this often. F of 23, that means I plugged in a 23. Now, I need to calculate 100 plus 10 times 23, and I'm just going to type that straight in my calculator. This part, not this part. I should get 100 plus 230. I don't have a calculator next to me, so I'm just going to do it. And 100 plus 230 is 330. F of 23 equals 330. We might need to write a sentence too. Jill will have $330 after 23 weeks. Okay. Now let's look at the next part. Here's our next question. If Jill wants to buy a car that requires a $1,000 down payment, how many weeks will she need to save? Okay, the $1,000 now represents the amount in the account. So we are going to put 1,000 there. 1,000 equals 100 plus 10W. It's important you know what each piece stands for so you can set up the equation appropriately. Now we solve. Subtract 100. 900 equals 10W. Divide by 10. W equals 90. It will take Jill 90 weeks. That's almost a full 2 years. It's not. So she probably will make it by 16, $1,000 by 16. Okay, we're going to open this up and try some more. Okay. Bob is driving home from his vacation to the Grand Canyon. If you haven't seen it, it's great. Actually, it's just a hole in the ground. I've been, but you know. Anyway, Bob is driving home from his vacation to see the Grand Canyon. When he stops to check his map, he notices he is 320 miles from home. He calculates that he should be able to cover 60 miles of road each hour on his journey home. He is 300 miles from home. That's important. He calculates he should be able to cover 60 miles of road each hour on his journey home. Let's write a function. We're going to come back to this, remember? F of, we don't know yet, equals 320. Okay, this is how far away he is from home. He is going back towards home. As he goes to his house, the distance he is from his house goes down. So subtract 60 miles, so M, each hour. Oh, just kidding. 60 each hour. Each hour. Okay. H stands for hour. I'm going to plug it in right here. This stands for distance from home, which means our independent variable is hour. Our dependent variable is distance from home. Our distance from home depends on the hour, or time traveled. Okay, now let's answer our questions. How far from home will Bob be after 2.5 hours? Well, that means we're going to plug in 2.5. F of 2.5 equals 320 minus 60 times 2.5. And I'm going to get my calculator for this one. Okay, and I'm going to plug it in just like it says. 320 minus 60 times 2.5. 170. F of 2.5 equals 170. So Bob will be 170 miles from home. We didn't live that far from the Grand Canyon. We lived further than that. Okay. Now, how long will it take Bob to reach his house? Well, if this function is the distance from home, if he's at his house, the distance from home is 0. So now we're going to solve. Subtract 320. Negative 320 equals 60h. Divide negative 320 by 60. By negative 60. I left off the negative, guys. And I got that h equals 5.3 repeating, which means we can make that into a mixed number. You know I hate them, but it's not going to kill us one time. That means Bob will reach his home or his house after 5 1/3 hours. Or if you want to be really precise, 5 hours and 20 minutes. Either one is fine. Okay, last one, page 29. I'm going to leave this one here. I want you to write the function and solve the questions. I'm going to zoom out so you can see the whole thing. There's the whole thing. I want you to do the whole thing. Pause the video, do it, and I'm going to go ahead and start. Marissa decides to offer a babysitting service to local families as a means to earn money to buy Christmas presents for her family. She decides to charge a flat fee of $15 for babysitting, plus $4 per hour, plus write a function, f of, don't know yet, equals, she charges 15, it literally says plus, 4 per hour, there's our variable, which means it's f of h. H stands for hour, f of h is the amount she makes, amount, I don't know how I want to say that, like I don't want to say amount she makes, let's call it earned, amount earned. Okay, so that means the independent variable is the hour. The dependent is the amount earned. The amount earned depends on the hour. Now let's solve it. If you didn't solve it yet, if you didn't answer these questions, pause the video, answer the question. How much will Marissa make from babysitting job that lasts 3 hours? H, so f of 3 equals 15 plus 4 times 3. 15 plus 12, 27. I just want to explain to you, if you are babysitting people, that this is not enough money. 3 hours for $27 is not enough. Charge more than that. All right, so f of 3 is 27. So after 3 hours, Marissa will make $27. Charge more. All right, last question. You should have already done it. You should just be checking now. The Smith family owes Marissa $29. How long did Marissa spend babysitting their children? This is the amount she earned. So 29 equals 15 plus 4h. Subtract 15. 14 equals 4h, and we're going to divide. Now I'm going to get h equals 3.5. Marissa worked for 3.5 hours. Okay? Alright, you've got that glued in. You need to finish the homework that is assigned today, and I'll see you on Monday.